Okay, do you see me and do you see my presentation at the screen?
Yes.
Okay, that's okay? Okay, thank you. So, my name really is Victor Kostarev. I'm the head of the Vibrosystem private company from St. Petersburg. And this presentation has been prepared with Dr. Frank Barutsky and my team, Dr. Dmitry Palov and engineer Irina Yavzikova. So I have to
Victor, I think you muted your microphone.
So, yeah, again, that's okay?
Yes.
No, it's okay. Okay, sorry about that. So the name of the report that we prepared for by request of Energiforsk is Summarizing of Experience on Operational Vibration, Eliminating of Nuclear Conventional Power Plants and Chemical Plants using 3D, three-directional viscodamper technology. We are consulting, structural engineering consulting company, and we have chosen a lot of number of damping devices like wire, like a tune mass damper for piping, like active sound damper experience, and finally we have been choosing the viscodamper as passive damping as the best option. So the report that was prepared for Energiforsk, and it should be published, I think. Monica will say you more, will share more current situation with publishing of this report, but it's 75 pages report on comprehensive experience on mitigating and eliminating of piping vibration at different facilities. So you can see the report content. Main of it, and on the further slides, I will provide you some impression on two chapters of this report. So the first, some basics. So I have to say that the idea came into the head of the Wilhelm Gerb in 1937. Yes, and it happened in Berlin. And then this technology was upgraded for years since the first application for in marine, yes, and then in other industries. The first application of viscodampers in the nuclear industry dates back to early 80s in the last century as a part of the Convoy project at nuclear plants in West Germany. But in 1985, the Russian design viscodamper was invented, which differs from the original design in the presence of additional internal elements and a special silicon-based high viscous liquid as working grease. So at the moment, the Gerb manufactured mainly two types of dampers for nuclear industry is VSS and VD, VSS with bituminol liquid and VD with silicon-based liquid under strict quality control by German TÜV. And since early 90s, more than 10,000 units of viscoelastic dampers have been installed around the world. So next, so the causes standards approval.
Victor, sorry,
yeah?
have you changed the slide? Because I think it's still the first one that's showing.
Do you see slide? No?
Yeah, I see slide number 1.
Slide number, no, okay, how it can happen, so what it is, how it happens, so.
Try to share it again and maybe use the presentation mode.
Yeah. Let's share it.
Yes.
Do you
Now
see
we
it?
see slide number 2.
Slide number 2, yes.
And
This,
if you try putting it in presentation mode
it's
to
okay?
make,
Now it's okay?
yes, it's number 5, but could you please put it into presentation mode to make it a bit bigger?
I will make it bigger, yeah. Here it is. It's okay? Code and standard approval.
It's still not in presentation mode.
Yeah, so I'm sharing my screen, but I see it's...
Now it's slide 6.
Oh, yeah.
Do you want me to share it instead?
Probably you will try to put it on the screen. I don't know. So, but so it should be. So here it is.
Can you see it now?
You can see now.
I'm
Yeah.
sharing the slide on codes and standards.
Yeah, code and standard approval. So, okay, sorry about that. So, for many years we use it in nuclear power plants, conventional power plants, chemical, petrochemical, and industrial plants, and offshore facilities. I have to say that in November 2007, the viscodampers was added to ASME code, and also for they exist in KTA, nuclear code, German code, and recommended by EIA for vibration mitigation and seismic resolve matters. Next slide, please. So regarding piping vibration criteria variety, so it's rather difficult question and problem because in comparison with the rotating machines. So there is a lot of criteria, but the main of them is the Waschel uh, norms and also VDE norms that we use in practice. As you know, there is some OMA ASME recommendation that have the threshold fatigue limit of 1 inch, 1/2 inch peak acceleration. Some Russian standards, but I have to point, first of all, that's the criteria we developed for LaVisa NPP on resolving vibration matter with upgrading of its power, and it was installed by 7.5 RMS vibra velocity. And I have to say that it's a really good limit to protect piping from fatigue. Next slide, please. So here is the examples of damper support. Some of them was presented in the previous presentation. Thanks to this presentation for the very good overview of different techniques. But here is an examples in the first row, examples of dampers application in containment areas. The left picture for the feed water line and in steam building also feed water line and other lines and condenser part. Next slide, please. I will not pay too much attention. I have to say that it was an extensive experimental works and program since early 80s to test all kind of dampers, including the Italy U Centra, the most huge test facility in Europe, and some small medium facilities at the GERT facility, BAM facility. And I have to point that in the middle upper row, it's the Russian facility, new facility, 3,000 tons facility that can test the huge dampers for isolation systems and so on. And also, please put attention on the left corner. Near is the early 80 years from 80 last century test in IHI shaking table with viscodampers, and finally the 2014 comprehensive test in Japanese program for starting up of the nuclear power plants that were shut down. And I have to say that this special test was used also for seismic matter as well as the operational vibration matter. So finally, in resulting of this test was developed the mathematical analytical model of all types of dampers that presents some four-step Maxwell model. Next slide, please. Here is the flow chart. So if you want to eliminate vibration, you have to follow this flow chart. Sometimes the using of viscodampers is not so successful as expected, but mainly in majority cases due that this flow chart was not realized. So it's very important. All blocks of the flow chart is very important to be successful in elimination of piping vibration. Next slide, please. Here is some examples of application. I have to say that it's numbers and numbers of examples in the report, but it's a few one, starting from the 1988 at the most powerful steam turbine in Europe, 1200 megawatts, and it was suffered with the very high vibration on main steam lines with pressure of 24 MPa and temperature 565. I have to say this operational process suffered too much with this vibration and have no ability to maintain it. So it's a first example of installation of VD dampers, and we have a very extremely high effect on eliminating vibration. And one of the last experiences that Colin PP, it's exactly the same to Lavisa in PP. Seems you can see blue line is the vibration, blue column vibration was before dampers installation, and finally red after dampers installation. The result is obvious. Next slide, please. And here is one of the latest results, experimental results on radiation resistance of dampers. Here is the silicon-based dampers that you can see this under radiation exposure, the damping parameters is even higher, a little high, especially in the region 5 Hz and less. And then it's more or less the same, even in a very high radiation zone. Next slide, please. For the VS dampers, bitumen-based medium, there is practically no influence on radiation. That means that both types of dampers, VD and VS dampers, can be installed in proximity of reactors. And we have such an examples when, for years, almost 25 years, one set of dampers is working in an extremely high radiation zone in RBK reactors, Chernobyl type reactor. Next slide, please. Here is some specific cases of vibration mitigation. It's a number you can see in the report, all description of these cases, and also explanation why some cases are very successful and why some other cases is not so successful. All of them decrease vibration essentially, but sometimes if you follow the initially show you flow chart, you'll be completely on a way to success. Next slide, please. Here is some aspects of technical and cost benefits of 3D technology against 1D linear dampers. In the previous presentation, there is some wording about that, but I want to emphasize on this point. So if you will compare two possibilities, two options to use approaches, to use 1D linear damping or 3D viscodampers. Next chart, please. Next slide. So regarding required number and primary cost. So in the left picture, you can see the primary cost And if for the 1000 megawatt nuclear pound unit, you need 750 units snubbers, you need 3 times less number of dampers due to 3D operating. So even in a primary cost, we have factor 3. But it's not so important in comparison with the maintenance cost. According to our experience and according to the US NRC experience and American snubbers problem, eliminating problem, you have absolutely dramatically lower maintenance cost in case of viscodampers, because you have to, snubbers is a rather complex mechanical system. So that means after years, it could be 3, 5 years, you have to disassemble it, to wash it, to bring to clear area, to test it, and then bring it back. It's a lot of cost. It's a lot of money. So that means that high viscous dampers do not need it. So you install it forever. In some cases, you can change the limit. You can change the liquid probably in 20, 25 years operation after. You can change on the liquid in outages, nothing more. Next slide, please. Regarding efficiency, so for seismic, it's approximately twice better. And for vibration mitigation, it's 10 times better. So our examples and a number of cases will confirm it. Next slide, please. And here is the very practical example of the new line, where it was the comparative study, what to do to install snubbers on the system or dampers. So initially it was installed 8 Lisega snubbers. You can show this GNP line is PWR reactor, yeah. And then it was substituted by 3 dampers only. It's only primary cost. And as you mentioned, the much more expense is devoted to maintenance costs. Next slide, please. And final remarks. In general, on the basis of comprehensive analysis and experimental experience, it could be concluded that using of 3D viscodampers technology is the best option for pipe and vibration mitigation and seismic protection in comparison to all other existing projects. At the moment, I don't know what will happen in the future. Probably it will be better technology than actual. But nowadays, I have to confirm that it's so as an engineer. So thank you so much for attention. I just 21 minutes, I think, passed in my presentation. That's all for today. Thank you so much.